Hi, welcome back to Spring CS170. I'm gonna continue or pick up on the first introductory lecture that we just had. This will cover basically a little bit of history on computing. But before I get into that, just want to update you on a couple of things. I updated the homepage for Canvas. When you go in here, you could go into modules and get to the student schedule, but I think because the student schedule is kind of pretty useful for everyone to see what they're got to do for this particular week or even the weeks that are coming. And I showed it to you in the last lecture, but I basically added here to the bottom here. So again, ideal thing is you come into your home page and whatever you need to do is like right here. Okay, the stuff on the left you can kind of click on if you want to go through it in a different way, but hopefully everything you need to know for this class or you need resources you need to access will be easily accessible just through this section over here. So that's why I kind of put the student schedule here. So I click student schedule, and again, I know in the video it probably comes out small. I'll try to zoom in as much as I can based on this. Whenever it comes up, like so, okay? And so you can see we're here, and I'll try to remind this on every lecture that we do. But you can see here, this is the week, Jan 19th, and some of the topics, here's the readings. We're covering chapters 1 and 2, and there's an introductory assignment. It's kind of like just an extra credit thing. During the beginning part of the semester, there's usually students that are coming and going, so we're trying to keep it pretty light here. And you just basically do this assignment, not really for like a regular assignment grade, like all these down here, but just for a couple extra credit points. And speaking of extra credit, I think what I wanted to do, usually what I'll do for extra credits, like throughout the lectures for the week, I'll pose some questions or some suggestions for people to send me email. And then what I do at the end of the semester is I just basically look in my inbox, I group everything by people who sent me emails and look at my engagement. And if my engagement looks like it's pretty good, have a lot of answers to the different lecture questions that I posed, you'll get full extra credits from me, the instructor extra credits, which is 10 points. Okay, so that's how I work the extra credit. So for extra credit for this week, what I'd like to do is basically almost just like kind of poll people and just make sure everyone can reach out to me. Send me an email, just introduce yourself, tell me a little bit about what you'd like to get out of this class and what you think about like how we've organized things and our different channels. If there's any feedback or whatnot, just send me an email. And what I'll do is I'll basically look through all of my emails and match that up against my class roster to see who hasn't sent me an email. And if you haven't sent me an email, I'm probably going to send you an email and reach out to you in the following week, right? So I find like this class, for you to be successful, you have to have some level of engagement with either myself or the TAs. So that's what I plan to do. Send me an email, introduce yourself, tell me about what you want to get out of the class, any suggestions or feedback based on what you've seen so far, and then I'll maybe I'll respond, or maybe I'll just say thank you, and then whoever hasn't sent me an email, I'm just going to send a follow-up email just to check on how you're doing. Are you in the right class? So on and so forth. Okay, so that's my extra credit for this week. Okay, so with that, I'm going to step over to here. Oh, and again, I promised everyone that I would remind people Piazza, right? Um, Again, Piazza, we want to really try to encourage that because we have like a whole bunch of different channels, emails flying around all over the place. Last semester, we want to try to reduce that a little bit, and using Piazza is important. So trying to encourage everybody to get onto Piazza. So look, you see here, we got 71 here out of like 700. So we still have a ways to go, and I know the class hasn't technically started yet, so it's fine. But let's get the engagement going on Piazza, get at least signed up for it, okay? So here we are. And as we point out these different topics, I'm going to try to maybe give you some thought, or say, hey, look, this is something you should know for the exam, or what you should know. This is like maybe just for your own personal interest if you want to learn more about it, and so on and so forth, okay? So I think for the last lecture, we left off on early computing, okay? So I actually fixed this before we had the pictures overlapping and the descriptions overlapping. So now I separate out, here's the Bacchus, and I can't even pronounce that. But basically these are like early mechanical or analog types of computing devices, okay? So you can think of this Bacchus as almost like a calculator type of thing. And then this is sort of like for astrology, astrological type of predictions. You've probably seen other cultures have similar types of things going on, but this is sort of like a mechanical type of calculator, okay, i.e. early computing machine. So Babbage, again, I think I mentioned in the last lecture, you know, at this point right here is probably the main thing, almost kind of like, you know, saying founder of a country or something like that, right? So Charles Babbage is kind of along those lines, right? The fact that he has a difference engine or the analytical engine, it's not like you have to know mathematically what a difference engine is actually doing. Just know these two ideas, difference engine and analytical engine, okay? So for the difference engine, it's kind of, you can just think of it along the lines of like, you know, various tables and things you might do to do like interpolation, right? If you guys are doing that in math, right? So that's kind of all you have to know. You don't have to understand any deeper than that. The analytical engine, what's kind of interesting about the analytical engine is that you know, some of the earlier computers was specifically programmed to do a particular thing. So you know, just because of like the effort it would require to do things, and the size of these things, yeah, they were kind of specially built. Versus like this analytical engine was kind of trying to lay the groundwork for like more of the general type of computing type of setups. And so you can see a lot of these different things here, like at the bottom, you see the arithmetic logic unit, the control flow, conditional branching loops. We're going to cover that more later in the class, but basically these are the kind of, these ideas are the precursors of like more of the general computing devices that you see now. Okay, so this type of thinking of making the computing more generalized to be able to do all kinds of different computing tasks versus like doing something specialized like what we were talking about up here with these guys, okay? So the analytical engine, the important thing to know here is that this lays the groundwork for more of the general computing devices that you're going to be seeing later on, okay? All right, so Herman Hollerith, the main thing is this, right? Punch cards, right? The whole digitized process. So what he did here essentially led to this, right? This 1890 census that we did in the US. So it was something that prior years, it was done by hand. It would take a huge amount of time to collect this data by hand, right? And we actually didn't have that many people in the United States back then, but it still took 8 years to handle the census by hand. But you know, in the 1890 census when they did it, you can see, right, it went from 8 years down to 1 year, right, which at that time was a huge jump in efficiency, okay? So that's where you get the punch cards. And you know, the punch cards were around for a long time, right? That's why even like in the not too long ago when we had the hanging chads for for the elections down in Florida, you had these punch cards. So the punch cards have been around for a long time, and maybe in some ancient system still running, but highly doubt it now. But that's what you should remember for Herman Hollerith in terms of like his contribution. And so you can see these punch cards here. Okay, so it would read in, and these little holes, the punch cards, it's the whole idea of like digitally you're looking at things as zeros and ones. Okay, and we'll go more into that in a future lecture, right? But that's the main idea here. Okay, and so this is just a larger picture or view of the machine, right? And again, like what I just mentioned before, right? So with Hollerith, digitizing information, representing things as zeros and ones, okay? Some people call it a presence and absence, PNA, right? So zeros and ones here, okay? And this is how this is all evolved, right? Because of this, okay? Otherwise, you might say, well, okay, instead of having 2 states, why wouldn't you have like 4 states or 6 states or 10 states, right? Digital, in terms of like the decimal system, right? We're running off of tens. So why couldn't you do that? Well, it's because of this, right? With the technology at that time, the easiest thing to do was presence and absence, like zeros and ones. With the current technology, we can have a different base, right? You can have a base 4, base 6, or whatever, right? Any number of different bases, because like either like coming over like the computer, or coming in over like whatever wire or wireless or whatever that comes over to you, we have a much better or much more sophisticated technology that theoretically you could be running with a different base, and you can get a lot more information in a smaller message, or the same message, I should say. But it's because of historical reasons why you end up in the situation we have now, where everything is, when we think of digital, is in terms of zeros and ones. Okay. So this is talking about essentially the first generation of digital or electronic computers, I should say. Okay. The key takeaway there, it's in the 50s, right, after World War II, and it's vacuum tubes. Okay, so that's the main takeaway. That's like essentially the first generation of these electronic computers. Okay, and they would be ginormous, right? They would take up the size of the room, right? And huge amounts of heat and everything else like that, energy and whatnot. Okay, and so ENIAC, ENIAC, is the first of these general purpose computers with vacuum tubes. Okay, and it was developed by the Army. So a lot of these things, even like the internet, has some sort of origins in some sort of military initiative, right, or GPS or whatnot, right? So ENIAC is one of those things. Okay, so the next step was to go into these things of like integrated circuits. Okay, and all that means is like you get into like transistors, right? And you get in like all these different functions, just like I was talking before about this general purpose computing, like all these different things, to get them burned into like a board, right? And that's what they mean by integrating these things, pulling these things closer and closer together, right? If these things are kind of separate, there's all kinds of implications in terms of the size, in terms of the performance, in terms of the energy requirements, in terms of the heat that it generates, all of those type of things. So that's why things have constantly evolved to get more integrated, build things that used to be separate, pull them all together into one place. That decreases the distance that they have to travel, and all the other benefits I just mentioned. Okay, so what you should understand from the first generation of computers to more later generations or closer to ours, sorry, vacuum tubes to transistors and integrated circuits. Okay, the transistor bit is a big jump, right? Because you can see the size of the vacuum tubes, right? These vacuum tubes are ginormous, right? To replace those with transistors is just like I can't even describe how much of a big difference that is, right? That's just like a huge amount of improvement there. Okay, so here's a picture. Uh, so you went from the 50s with vacuum tubes in essentially the 60s for the transistors, right? So the whole thing with AT&T, Bell Labs, that type of thing. Um, that's what you want to try to remember from a historical standpoint on the evolution of electronic computers. Okay, and remember, I've drawn the distinction between electronic computers versus like what they'll call the analog, or I would say mechanical computers from the early computing that I highlighted before. Right, and kind of more of the latest generation is the integrated circuits. Okay, and this is where you can see like they're squishing more and more stuff onto a single board or more ultimately onto a single chip. Okay. Right, so I would consider like this to be late 60s, 70s. So you can almost think of it as like three generations as essentially the decades of 50s, 60s, and 70s. 1950s, 1960s, and 1970s. Okay? And and we have the microprocessor, right? And this is where I was saying that you have all of these different things instead of just being on the board like this for your integrated circuits, is now you're actually putting everything onto the chip. Okay, and this is taking it from 70s kind of forward right now. Okay, so hopefully you can kind of keep that in mind. High level, not talking about the exact details of exactly what each of these types of processing does, like what does the vacuum tube do, or what does the transistor do, or whatever. But just understand like these are the different generations and kind of what the implications were in terms of the size and the power of the computing. Personal computers gets into like graphical user interface, right? GUI, as it's commonly referred to. Uh, Xerox, something you want to remember, right? That ties in also later with things with the mouse and stuff like that. So that's early 70s, okay? And GUI, remember that, okay? Early personal computer or mini computer, I should say. Here, this is Altair 8800. It was kind of like a very, almost like, your home mechanic to work on your car. This is kind of like those type of people putting together their own computer or working on their own computer. Okay, so not really what I would say a personal computer for like the average person. Um, More of like a very technical type, hands-on type of person, almost like the mechanic, home mechanic for your car. Okay, so that's what this Altair 8800 was. So here with Apple II, this is really the big breakthrough from a personal homeowner, like a personal computer perspective, right? This is where a normal person can kind of use this, right? And we're going to be doing spreadsheets in this semester, but this is the first one that came with that, which is really became something that was very useful. So many people developed so many uses out of spreadsheets, and this is the start of all of that. Personal computer, Apple II, VisiCalc. Um, that's really the breakthrough from a home user perspective, a personal computing perspective. Okay, and then the IBM equivalent of that, right? It's always distinct between Apple and IBM, um, or Android at this point, is their computers, right? So And there's some distinction that we'll get into in terms of like the GUI or the user experience difference between Apple and IBM. Okay. And what makes a computer? We have the storage devices, you have input, you have a processor, you have output, right? So this might be like your memory stick or some local memory on the computer, um, cloud storage these days, right? And then you have your processor. Again, you can have your local computing, it could be a cloud compute, uh, just where all your calculations happen, right? So storage, that's your memory, this is your computing. Your input device is like your keyboard, uh, whatever you use to get information in. Um, and your output could be just your monitor, right? Just displays some output, could be out to like a printer or something else to send out the output of what came out of these calculations. Okay, so I want to pause here because I'm already hitting the 20-minute mark. I'm going to cut another video to finish up the rest of all of this here. Okay, all right, thank you for your time.